In this video, we're going to talk about two parallel wires, each carrying different currents, or they could be the same, doesn't matter. And we'll talk about how they affect each other. Now, in very simple terms, if the currents are in the same direction as shown, then the force that the wires exert on each other will be attractive in nature. But if the currents are in opposite directions, okay, like what I'm going to highlight over here, then the force on the two wires will be repulsive in nature. But what we have to be aware of is that in either case, the two forces have the same magnitude but are in opposite directions, and hence they form action-reaction pairs. And so some people call that an N3L pair. What we're going to do now, okay, the way in which we study each of these systems is exactly the same, and so we'll simply study one of them, and we'll choose to study the attractive one. And so we have to figure out, how do these wires actually exert force on each other? Well, note that each of these wires carrying currents can create magnetic field. And so considering IA, if we use our right hand grip rule, our thumb points upwards and our four fingers wrap around this way, you'll find that the field that IA creates at IB will be going into the paper like so, and so we'll call this BA. And if we do the same thing for the magnetic field produced by IB, you'll find that the magnetic field at IA due to IB is coming out of the paper like so. Now, if we use Fleming's left-hand rule, this one, you will notice, okay, if we look at this wire first, okay, that the magnetic field goes out, so second finger points out, the current goes upwards, so the third finger points upwards, and true enough, your thumb points to the right. And if we do the same thing for this wire, you can easily prove that the thumb points to the left. And so we got the directions in. Now, what about the magnitude of these forces? So because these wires are infinitely long and they are kind of uniform throughout, it makes more sense to calculate something called the force per unit length on each wire. And so since FB equals to BIL, then F over L is simply equal to BI. And so if we calculate FB over L for, let's say, this wire over here, that will equal to BB times IA. And we know that BB, the magnetic field strength created by a current in a straight wire, is mu naught IB over 2 pi r. Okay, this can be your r over here, multiplied by IA. And that is the formula for the force per unit length between the two wires. You can repeat the calculation for this wire over here, but you will be very pleasantly surprised to figure out that it's going to be exactly the same. This time it will simply be BAIB, and a simple calculation will show you, or should I say, a simple expression will show you that the values are indeed exactly the same. And so the forces on each wire are equal in magnitude and are equal in are opposite in direction, and so they do indeed form action-reaction pairs.